tell me what status of so we can proceed to the next proceeding. It's also a sign.
Dear colleagues, dear participants, I'd like to first of all, 1 second, excuse me, so people are coming. So let's proceed within our session, and I hope that Rafael Wandiku can hear me. Rafael, can you hear me? Can you just confirm?
Yes, Professor, can hear you.
Perfect, Rafael. Thank you so much. I would like to give you the floor for your presentation, which is entitled Improved Medical Imaging Transfer Learning Through Conflation of Domain Features. Rafael, I would like to give you the floor and make use of the time, which is around about between 10 and 15 minutes. Thank you so much.
Okay, thank you. So I hope you can be able to see my screen.
Yes, we can. Thank you.
Okay, so my name is Rafael Njiko, and my co-authors are Carol and Sindelu and Panaiko Kimole, and we have worked on a topic on transfer learning titled Improved Medical Imaging Transfer Learning through the Conflation of Domain Features. Which one my profile, I'm a PhD student, information technology, specializing in AI, looking at transfer learning at Jomo Kenyatta University of Information Technology. And my interests are in computer vision, machine learning, software engineering, and programming languages. So we're going to have a look at the introduction of the conflation, the problem statement, contribution that we are bringing on board, the existing literature, methodology, result and discussion, and the future work that will be the communications. So we all know that deep learning has been the forefront of advancement in AI applications, and medical applications are not in that. And deep learning has been used in classification, in segmentation, and transfer learning is one of the things that have also accelerated the use of deep learning in medical applications. We use in skin cancer detection, Alzheimer's disease detection, foot ulcers, and histopathology, looking at medical imaging. So, transfer learning has become the more straightforward route when you want to have a look at deep learning and use it in medical imaging classification. So, all what transfer learning is reuse of previously learned knowledge of an already existing model that has been developed with a lot of data, and you use that learned knowledge from that model and use it on another task. And ImageNet has been one of areas when it comes to adaptation of retained model. And in medical imaging, ResNet and DesNet are the most used retained models. So what is the problem here? So the problem is that in medical field, there is lots of data, and some instances there is not a lot of data because some of them is limited, we take it into electronic format and all that. And in medical images, the question of how feature reuse has always popped up, and especially due to the variation of textures in pathology. And there is also a question of what are the success factors that transfer learning looks into and enables that accurate classification. So studies have looked into the aspect of low-level features, and we are bringing the aspect of conflation to be able to assist in terms of variation in terms of texture. Therefore, this work addresses dual target domain adaptation by use of conflation of textural features between the source and the target domain in using transfer learning. So we are proposing the conflation of extracted CNN features, and again, we are bringing the aspect of better quality target data set, because you can imagine a case where you misclassify a melanoma from another type of cancer. That would be a totally different diagnosis, and can actually lead even to a death of patient. And we also bring the aspect of bringing better terms of increasing the chance of the model, thereby reducing current trial process and error in selecting the treatment models. So in terms of existing literature, transfer analysis is used in X-ray images to detect pneumonia, in COVID, and as well as in doing histopathology, in doing melanoma, classifying of lesions, and even some more work has been done in conduction to looking at measures that can actually be used, taking the case of Shevchenko, when they use the maximum light principle using full-back regular divergence. So this is a model that you're proposing. You have a pre-trained model. So this is a pre-trained model. And from this pre-trained model, you select the first layer of convolutional network. And from that convolutional network, you extract features from the source images and preferably from the image data set, and you're going to have some features. Then you go to the target domain and you get the target images, use the first convolutional layer. And in this case, the convolutional network that you're using is the same pre-trained model. And the reason why I decided to use the same pre-trained model, use its convolution, is because it will be the last pre-trained model that we use to do the classification. So we're kind of simulating extraction of these features in the final environment. So once you have the features of the source and the features of the target, to have them here, then you can be able now to do feature match selection using full-back regular divergence and even other measures. Then you do now your fine-tuning and of course your transfer manager. So in this methodology, we are calculating the textural probability distribution of these features. Once you have these probability distributions, we are putting them into single-dimensional vectors. And from single-dimensional vectors, we can now be able to compare them using full-back regular divergence. Once we have the full-back regular divergence measures of these images in both of those domains, we can be able to select a mean full-back regular value that will help us rank these images whether and we're using full-back regular divergence because of its reasonable type and memory complexity relation to their measures. So these are configurations, and if you have, so we can calculate that one into a probability distribution X this way, and we can express this further using probability density functions. So this one is for discrete probability distribution of its probability density functions, and this one we just integrate it for the most probability to be sure. We can be able now to proceed on further and conflate the features. So conflating our features, if you pick an image I, you can be able to get features of the I from 1 all the way to n and conflate it by getting the product of the probability density functions from 1 all the way to n, and then we divide by the integral of features from 1 all the way to n. Once we have the conflated features of one image, we can be able to do and repeat the same process for all the images in the source and the target. And after that, we get the full-back regular divergence values using equation 5, and from there we can be able to rank them based on the mean full-back regular divergence. So we did the methodology using 3 data sets with about 14,000 images for training. Test X-ray dataset of 3,200 images with just 4 passes out of the 14 disease categories, and an I6 skin cancer melanoma set 900 training images. So for the pre-trained model, we have used 2 pre-trained models, MobileNet V2 and BaseNet 121. The V2 is to enable us to see how that model feature in low resource limited devices like mobile phones. And the DESNet 121 repository has been commended as one of the best architecture when you're working with medical images. Trained on paper-space platform, using TensorFlow with stochastic gradient descent or with a learning rate of 0.01, handled epochs, and regularized with a dropout of 0.5 and batch normalization. For experimental methods, as mentioned before in that approach, we extracted the features using the first layer of the pre-trained model themselves, and we analyzed those features using linear binary pattern and gray-level concurrency matrix DLCM. Specifically looking at three properties: energy, correlation, and homogeneity. So in understanding these results, because we're looking at improving the accuracy or the performance of this model, look at three metrics: accuracy, precision, and recall, then compare how do the two architectures perform. So if you look at the model with Net2, this is the accuracy results and these are the precision results. If you look at the correlation in terms of the GLSM properties, correlation gives some better accuracies in comparison to the other two, energy and homogeneity. But of importance is how the values that were below the mean performed. So if you look at the ones labeled DLW, these are the ones below. This is 94, this is 88, this is 92, 91. And the trend actually repeated itself across the LGBT properties. So the same case, of course, to cement more on the accuracy, then precision gave the same results from this table. So graphically looking at those results, this is how the performance can be visualized. If you look at the images that had properties with lower probability by divergence than red, you can see that their accuracies were above the ones that were above the mean. For this is from the LP, looking at the COVID dataset, correlation properties, DLSM looking at the chest X-ray, and homogeneity looking at the skin cancer dataset. Looking at the other pre-trained model, the DenseNet 131, the same trend actually happened. We have the ones with below giving higher accuracy than the ones which are up the mean. But again, slight difference in terms of which property in GLSM gives better properties. So in the other case, it was correlation. This time it was energy, but homogeneity still remained in its position. So the same case for recall, and the values actually shows better performance. So again, visualizing that, this is what we have, the same trend. And from that, we can be able to say that lower values of feedback required divergence give better accuracies in all the three performance metrics, that is accuracy, precision, and recall. We also noted that LBP gives better performance than the GLSM properties, which in correlation gives good relation with the mobile net with 2 and energy better performance when it comes to DenseNet 121. However, LBP communicated those results. So for the homogeneity, we can say the way it was actually stable shows the uniformity and simplicity of the textual features. It gave good feature adaptation, hence got better values. And this was as a result of increasing the density of the images edges, reducing the distance between the textual parties. LBP can be attributed to the various illumination variations of the textual parties in the image features. So in conclusion, so we can see that if we can be able to complete features using textual properties, we can be able to bring better adaptation of images within the target task using the source task of the pre-trained models. And we have used DLSM and LBP and textual features, they do affect, and lower divergent values can be able to improve this performance adaptation, which is, of course, coinciding the list literature using the divergence in evaluating information loss. So these are used in enhancing the imaging and are scenarios that are in classification as Parlament, but as of now, it has not been worked with image data, and we hope to actually extend to in other types of data. So in the future work, we expect to look at other pre-trained models and data sets to further validate these results, and other law features can be explored, determine the effects of main data adaptation and population, looking at things that would do with signals and the kind of networks. Thank you, Prof. And I would like to welcome questions, clarifications, and comments. Thank you.
Thank you very much, Raphael. Well done. I really liked it. And I'd like to open the room for discussions, for questions. Who wants to start? Nima, please.
Okay, thank you very much, Raphael, for the very nice presentation. So my interest is to understand, I know there is challenges of obtaining the medical data set. So for your case, how did you obtain this data? Did you collect it by yourself, or you have used secondary available data sets?
I think as you're mentioning, the challenge of getting primary data sets. So I look for data sets in Kaggle, papers with code. That's where I got my data set, even just to help in terms of comparing how these data sets perform in other instances.
Thank you so much.
Yes, they are publicly available.
Raphael, can you go back to your problem statement in the beginning, what you wanted to look at, and how you approached it with, referring to also what Nima asked, so the collection of data, was it like organized, pre-organized, or how did you obtain it? Maybe you can go...
Yeah, so this data set...
Yes, sorry.
Yeah, so these data sets are already organized, and I think they can be able to provide you database where you can be able to get these data sets. So as I mentioned, I looked into papers that already worked with medical imaging data sets, just to make my work more credible in terms of if someone would want to repeat these experiments, how can they be able to get this data? So that data is actually available out there, and you can be able to get it. So Rob, I didn't clearly get the second part. So something you asking about the project.
Okay, thank you. Any question?
Yeah.
Helmut.
Yes, concerning the data sets again, did you do any filtering on this 108,000 data that you adapted? So I think they are very raw in that case, this public set. Do you have any filtering mechanism, data selection in advance?
Come again?
Can you hear me?
Yes, now I can hear you.
Raphael, can you hear me?
Yes, now I can hear you. Do you mind repeating your question?
Okay, asking again? Yeah. Did you do any filtering on your data set? Because these public data sets are very raw data to my knowledge. Did you make a special selection or filtering of that data, which which had to then be used for the system?
Yeah, so actually the data sets, I use them the way they are, and the reason why I use them the way they are is because I've already been filtered and organized into several categories.
Okay.
As you can see on this slide, I've mentioned that for the chest X-ray, this is the second data set. It has over 108,000 images. But from that, which are 14 categories, I only selected 4 of those categories.
Ah, okay, I got it. I did not get that. Okay, yes, thank you, Raphael.
Good. If there is a last question in the room, from Nima, yes, please.
Okay, so Raphael, maybe can you share with us which approach did you use for feature extraction?
So for the feature extraction, I can just go back to the approach that I'm using. So there is a pre-trained model, and this pre-trained model is the one that you're going to use to do the transfer line. So we decided not to consider the older traditional methods of data extraction, like the Gabor filters and the rest. We decided to pick that same pre-trained model, so this is a pre-trained model, then looked at the convolutional layers which has been cited in future would work the same way, just like the Gabor filters would actually do. So we used those convolutional layers to extract the features themselves. And this again was hinged on the fact that this pre-trained model is the one that you are still going to use to do your final transfer line. So it kind of simulated how it would happen, even if you are not to do the fine-tuning and just go with feature extraction for transfer line.
Rafael, Jorge here again. Are you, as far as I understood, you're working on your PhD right now? Is this correct?
Yes.
And with the same topic?
Actually, this is a part of the bigger thing that I'm working on. The other part involves looks into the convolutional layers, how you select top layers. So this is part of my work.
Okay. Good. Thank you so much, Rafael. I'd like to give you clap. So thank you. Before we move to the last presentation of this part of the session, I know that Shabani is still with us. Shabani, can you hear me? Shabani, can you hear me? There are lots of, by the way, there are lots of chat messages, colleagues. Maybe they want to ask a question. You have to look at it. Is there any question, even to Rafael? Sorry for coming back to the presentation of Rafael. Is there any question from the online participants to Rafael or to Shabani, which I hope we can hear again? Okay, this is not the case. Shabani, can you hear me? Maybe you are muted.
Yes, I can hear you.
Yes, Shabani, great. Unfortunately, we were interrupted during your presentation several times, and since you are a student, an Emos student presenting also a poster, I would like to give us the chance for one or two questions, just to have a better impression about the results you obtained. Can you, Shabani, once again refer to your problem, definition and problem statement? Just maybe some few sentences on it, and how do you methodically approached it and presented a result? Because it was very difficult to follow. Just briefly, give us some ideas what you did and how you elaborated the result.
Okay, my title was the object detection for poultry diseases diagnostics. So actually, the problem was for a case of here in Tanzania, as our economy in Tanzania depends largely on the agriculture, and livestock farming is part of agriculture. You find that most of these poultry are being affected by the diseases, and in tackling this problem, there are two challenges. The first one is the distance, because these veterinary officers are located far away from where the poultry farms are, so it's very hard for them to attend the cases on time. And the second one is their coverage, these veterinary officers' coverage. For a case of here in Tanzania, the veterinary officers at the district level, and you find that one district can have up to 30 or 40 wards, and a single ward can have up to 20 or 30 poultry farms. So like it's very hard for a single veterinary officer to attend 200 or 300 poultry farms. So I decided to come up with a solution, and my solution uses a machine learning approach in ensuring that we get fast, accurate diagnostics of these poultry diseases. So basically, the problem statement as well as my solution.
As far as the data is concerned and the images you collected, can you just tell us how you did it and how do you include that in the overall work?
Okay. All right. We collected a sample of the poultry feces. Poultry feces images as the input to my model, and we collected these samples from northern Tanzania, which is Kilimanjaro, Arusha, and Manyara regions. So we had a total of around 2,000 poultry feces images. So these images were collected based on 4 classes, which are the healthy class, the coccidiosis disease class, the salmonella class, as well as the Newcastle disease class. Thank you.
Thank you, Shabani. Well done. If there's a question from Isaac, our Vice Chancellor.
Thank you, Shabani, for the nice innovation in terms of the research you're doing. I just wanted to, because you are talking about collection of feces, you are sampling the health animals and maybe the affected ones. But how reliable is it for the Newcastle disease?
Okay. For a Newcastle disease, first of all, we got an approval or a certificate from the government, because we hope that the Newcastle disease, once it gets it, then it will no longer survive. It will no longer survive. So we had to inoculate some samples. We were given an approval, so we vetted the diseases. The disease we injected to a sample of the poultry, and then we got the feces.
Okay.
But before that, we got an approval.
Yeah, because I was thinking maybe if it's your model is going to work, then you would only focus probably on what you can detect in the feces, as opposed to maybe something like Newcastle, because by then the animal is dead. So it understands. Maybe you need to rethink whether to narrow to only coccidia and the other one, salmonella. Yeah. Well, that's my suggestion.
Yeah, thank you for the suggestion. Thank you so much.
Nima.
Okay, thank you so much, Shabani. I've seen that you have done a very great job of developing a model and even deployment part. So my interest is to understand, what is the plan? Are you planning to expose the model in the real-life environment and see how it's going to behave, or what is the next plan after this kind of deployment?
Yes, thank you so much for your question. Yes, I am planning to do a future work of developing an application whereby it will have a very simple interface, so that even a layman can understand it, so that a farmer can be able to capture a picture, and then the model will tell if the picture that he has captured is for a diseased or a healthy chicken.
Thanks, Shabani.
Thank you so much.
No, well done. Is there from online participants, are there any questions to Shabani or to Raphael? This is the final chance. Can you go to the chat, please? No questions, okay. Then Shabani, thank you very much once again.
Thank you so much.
Well done. So we are now moving to the last presentation of this part of the session before having the health break. And the presentation is entitled Intermodal Matching Algorithm, including public transportation and ride-hailing. This presentation comes from out of my group. And Sven von Höfeling, can you hear me? Are you with us? Sven, bist du da?
Hello. Hello.
Hello,
Okay.
Sven. Great.
No, Sven is not here. I'm Sasapu. I'm going to present.
You are going to present at Sasapu. Okay, good.
Yeah.
Welcome, Sasapu, to the conference. And can you join? Can you share the slides with us? Sorry. And make yourself shortly visible and introduce yourself and shortly and go then to the presentation. Thanks, Sasapu.
Okay, can you see? Okay, just a minute. Can you see my screen now?
Unfortunately, not yet.
And now?
No. It looks like.
I shared my
Yes,
screen.
we can see it.
Okay. Thank you very much. Good morning, everyone. Thank you very much for being a part of this conference. Myself, I am Sasapu Venkatesh. I work as a research associate at the University of Oldenburg in Germany. Today I am going to research model for the intermodal matching algorithm for integrating carpooling transportation. Carpooling system into a public transportation system, which is a part of a NM-AIST project. So first, I would like to start with my agenda, introducing about my project, and then I'll just go to the little background behind the project, and then furthermore I'll talk about the motivation and what are the problem statements behind it before starting this project, and of course additionally I'm going to talk about the matching algorithm for the carpooling system. After that, we are going to talk about the proposed model for the intermodal matching algorithm. Finally, I'm going to talk about the challenges that we are facing with the intermodal approach, and then future work as well. So, my project is NM-AIST project is funded by Ministry of Science and Energy Technologies, against the background of demographic shift by considering sustainable mobility as a main goal. That means the University of Oldenburg has joined and hands with our industrial partners, which is feedback, and as feedback is a company where they are good at making user-friendly applications for elderly people. Mathread is also good in carpooling systems. So let's get back to the background of this project. Like, you see the demographic trends in Germany. You can see the diagram here. The left side it will show the demographic for Germany, and the right side, if you move from, it will show the demographics for the European Union. If you compare it, if you move from left to right, these numbers are keep on increasing year by year. The people who process more than 60 years in Germany are around one-fourth at this moment. This number will be increased by 2050 up to 1/3 of this present stat. So at the same time, the people who process the age more than 80 years, it will go to 1 out of 8 people. And surprisingly, these people wanted to live in villages. So and also Germany is having more than 90% of the land area is filled up with rural area, which is almost, we have more than 90 million people in Germany. So out of it, 50 million people are already living in the villages. So for them, almost 90% of the people who are living in the villages having their own car, but whereas in the villages, train connection and the bus connections are not so frequent. You usually see in cities, even if you don't have a own car also, you can go with the bus train connection. So considering age groups of old age people, these people anyhow they wanted to live in the villages, and we wanted to provide a better transport system for these people. So now I'm gonna talk about the say, for example, these two to meet a doctor. Now it is a difficult task. As the age factor is one factor, due to that age factor, the fatigueness will be increased, and as a result, it will be an accident if they are driving their own car. See, other people as well. So here in this case, the problem, let us assume old people wanted to travel from village to the city. He used to have to call a daily ride. He will book a car and then he will take either a car or a train and then he will go. After this system, what we wanted to do is we wanted to integrate this along with the public transportation system as well. So now in his mobile or a tablet, he can see the combined timing as well as the connection, so that he can reach his destination wherever he wants. In the next slide, I'm going to show you how he is going to see in our system going to see in your front end. Oh, sorry. Okay. What it will make better mobility. So in this case, the citizens who will be a part of this carpooling system, as a result will increase the occupancy rate of the vehicles, as well as will raise the cost and emissions for the person as well. Ultimately, it will lead to a sustainable environment. So here, our central approach is to you being a older people, you have an option to select kind of an appointment. Let's say you have a doctor appointment or a birthday event. Like each appointment, it will be shown in different colors. Then you will filter it with your time, and then you will select pick-up point and ending point. So you will get a list of stops. So out of it, you will get connected. This is how our travel consumption should look like. Apart from this, we also have implemented preference. For example, if the user wanted to take a music system, so he can select only the ride offering people for music or smoking or whatever it may be. These are an extra filter that he will let us assume he has he can also select the time. So our actual carpooling system works in the principle of detours. These detours I'll send you in minutes, and then after it filters, then you will get the possible route. So the answer for the carpooling double pooling system. So let's say this is your pickup point, and the other one is the drop-off point. This matching algorithm works on a principle of G2, which is a limit of maximum of 2 times of 5 minutes, which is 10 minutes from the drop-off point or the pickup point. So in this example, we have 3 routes which was created by a driver in a region, So if you see this picture, route 1 and route 2 are passing to this detour or isochrones, and then the user will get a route of route 1 and route 2 in his output. But whereas if you see the route 3, this is not matching to this isochrone, so or a concentric circle. So at the end, this route will be eliminated. So this is a problem here, because let's say if your pickup point is closest to any of the routes, that's fine, or a drop-off point also. If any of your pickup or a drop-off point which is far away from the route was created by a driver, then passenger will not get any route. So this is a difficult task for this system. So for that reason, we wanted to modify this system into a carpooling system along with a public transportation system, because this limit is limited for the carpooling system. So in another slide I can show you the route from both in picture 357, the route was created from 1 to 4, and 2 and 3 are the points which is closest to the route which is in 10-minute limit. So this driver can take a detour from 1 to 2, and he will pick up from 2, and then he will pick up the person at 3, and he will take this destination to this 4. Similar to this 357 or 387 is also the same, just an extra picture that I have shown it to you. So now carpooling system, everything is fine, but it has a backdrop of only it can take maximum detour of 10 minutes. So and in the villages, we know public transportation in rural areas, bus stops are limited, and it is also difficult for a longer distances as well. So in this case, we wanted to come up with a combined model for public transportation system as well as a ride-hailing system. So as an end user, we concentrated it here for older people. So we wanted to make a change from public transportation to the carpooling system to one. We just limited it to one change. So after we allowed only for one change, we only have two cases here. One is either he can take the public transportation system, and then he will take the carpooling system or ride-hailing system. Second case, ride-hailing system, and then he will take the carpooling system. So in the next slide, I am going to show you the pictorial representation. If there are 3 rides are
Sazapu, may I interrupt you? Sorry for that. And you have 3 minutes to go, please.
Yeah, sure. It's almost finished. Yeah. So here, if you see this carpooling, the 6 black lines represents the ride already existing. A and B are the pickup points and drop-off points. This A point which is far away from this carpooling system. So now we cannot take this. We cannot take this pickup point. We don't get any route for this system. So at this moment, we wanted to implement a bus stop first here. So our system will take here the nearest bus stop from the defined route, and then it will give the connection from either A5 or A4 to its drop-off point. So here, just a pictorial representation of how our drop-off point and drop-in point and drop-off point for a existing ride-hailing system that we are working. So point A and B, as the point A is too far from the existing ride-hailing system, so it will give a null set. So we don't have any routes here. If you enter from point A1 to B1, it also gives the null set, just because which is also far away from the system. So again, our system will check A4 and A5, then it will give the route to the end user here. So let's come to the challenges in this implementation as well as my future work here. So the integration of carpooling system into the public transportation system is still undergoing, and also the computation time for this carpooling staff, the public transportation staff, and each route is has to be calculated, so it will take little longer time than expected. So these are the major challenges that we need to figure it out. And the next thing, future work, we also need to make a prototype of it, and then we wanted to test it in front of the group. Thank you very much for your attention. If you have any questions, want to contact me.
Thanks, Azapu, for the presentation and the insight views on the project Remobias and its characteristics. I would like to open the room for questions to you. Who wants to start? Are there any questions? Azapu, can you just maybe for us once again explain briefly what the Remobias project is about and how the matching algorithm was elaborated?
Yeah, so the Remobias project is basically it offers an optimal mobility solutions for the people, those who are living in villages, by using preferences as...
Can you go to the slide, please? Sorry. We just see the final slide, which doesn't make...
Oh, yeah.
Or doesn't give that much input.
Okay. Yeah. Yeah.
So just briefly about the project and the matching algorithm. Yes,
okay.
Yes. Once again, this was fast.
So there are two matching algorithms here. One is for the carpooling matching algorithm, and another one is for the integration matching algorithm. So which one you are talking about? Which one you guys wanted to know? Because first one is carpooling matching algorithm.
Yes.
We will modify this carpooling algorithm to integrate public transportation system into the carpooling system.
What? Sorry, once again. So what? The first one. Can you just refer to it? So what is it doing? Can you go to the full screen mode, please?
Yeah, sure. Can you see me?
Yes.
My screen now?
Yes. Thanks.
Okay. Okay. So I'll explain you here how this matching system works here. So let us assume there are 3 drivers here.
Yes.
They put their route for the carpooling. So now, so our model is working on this isochron or concentric circle, which is having a limit of maximum 2 times of 5 minutes, which is 10 minutes for the G2, for a pickup or a drop-off point, both any point. So if your route created by the driver is closest to the pickup for a drop-off point, then our system will give the route to the passenger. Otherwise, the passenger will not get the route. If this pickup or a drop-off point is little far from the more than 5 minutes or 10 minutes, or 2 times 5 more 10 minutes, then he will not get any route.
Okay, and just briefly
so
to
in
the...
this case, it is difficult.
Yes, I understand.
Yeah.
Can you just again refer to the one about ride-hailing? And maybe you can explain briefly to the participants what ride-hailing means.
Oh yeah. So now this intermodal approach here. So as the pickup point is far away from the ride-hailing, so now the user cannot take the ride-hailing just because this pickup point is little far from the ride-hailing. Let's say more than 10 minutes. So now what our system wants to do here, first our system will check with the nearest possible bus stop.
Okay.
These A1, A2, A3, A4 are the bus stops, public transportation stops.
So ride-hailing means a tour which is done daily by a driver, right? And
Yes, yes.
okay, and you identified a pickup point A, which has a certain distance with a certain time to be picked up, right? And you define the pickup points in advance, or are they spontaneously done? Based on this.
Spontaneously.
Okay, good. And the B, the drop-off point, how is this created?
At the moment, it is this B point is just closest to this ride-hailing point. So, I mean, we are just trying to make it in cases, right? And it is all about the first case, right? So, second case is vice versa of this first case. So, the B point is which is close to the ride-hailing.
Oh, okay, good. Thank you.
Maybe a question.
Is there a question? Yes, Isaac. Sorry.
Yeah, I'm just trying to imagine how different this application would be compared to like what Uber is using at the moment.
Yes, very good question.
Yeah, what would be the difference? Because if you modify the Uber one, it will most likely be the same.
Yeah, but okay. And Zadapu, did you get the question?
Not really.
So the question from Professor Isaac was what the difference between this Remobius approach compared to Uber. What is the difference?
Oh yeah. So in the Uber, you will only get the ride-hailing systems. You will not get the public transportation system combined. So in this system, we combine both public transport system as well as carpool system or ride-hailing system.
Yes. This is the main difference.
Uber.
Yes. Sorry, Sosafu. Excuse me.
Yeah, I'm done. Thank you very much.
But there's one other major difference between it. If you compare to Remobius directly, right? This is the transport of elderly people.
Yeah, exactly. I mean, that's the main target of this project. So we mainly focus our target audience is elderly people. We wanted to have them with proper
Yes.
transportation system to reach their goals. Let's say, as I mentioned earlier, if they wanted to meet a family, if they wanted to meet a family in cities or something like that, they can use this system.
Thank you. There's a last question from Gerrit.
Hello, Sosafu. Thank you for the presentation. I also have a question. Maybe I missed it, I don't know, but did you already, or are you planning to evaluate this approach, this matching approach, and if so, how do you want to evaluate it?
So at the moment, we didn't evaluate this. We are just under planning now. So it's not yet implemented, so we will do it as soon as possible.
Okay, so now it's more of in the state of a concept.
Yeah.
All right, thanks.
Okay, then I think we are. Thanks, Sazapu. I think we are done. Also, because of the time is quite running, so we have to stop here. Sazapu, thank you very, very much.
Thank you.
Dear colleagues, participants, I would suggest, since we already took a 10 minutes break, to continue right now in order to spare some time. Nima, what do you think? Shall we continue directly? Anything against it, then I would recommend to do so. There is no... Devota, sorry, I didn't see you.
No, I'm just saying, did they take breakfast?
I mean, we can take a very, very, very fast breakfast. I mean, but maybe just let me just ask Mick Geisthard. Can you hear me, Mick? You would be the next presenter. Nick, can you hear me? Can you check?
Hello.
Hello,
Yes,
Mick.
of course, I can hear you.
Mick, do you mind if you give us a 5 minutes break, although we are quite advanced as far as the time is concerned, because we had technical problems, and so we might make a 5 minutes break if you don't mind. Can you?
Yeah.
Is it okay for you?
Sounds good. Yes.
Okay. Thanks. Yes, Mick.
Yeah, that's good.
Thank you so much. The same, the question to Mena. Mena, can you hear me? Are you available?
Yes.
Would you mind if you are also shifted a little bit later to a later presentation, just like 5 minutes break now, and then of course following the sequence, Mick, you and Daniel. I know that you are with me here. Daniel, can you hear me?
Yes, no problem.
Thanks, Daniel, for that. And Henry, can you hear me? Henry, are you here with us? Is Henry from the Tanzanian part? Nema and yeah? Okay, good. Then we should inform him that we are a bit late. Then thanks for that to all presenters, and then we would make a maximum really of 10 minutes break to have just a little bit of coffee. Thank you so much, and thanks for understanding. See you in 10 minutes and hear you in 10 minutes as well, of course. Thanks.
Just 4 questions. He needs to present the problem statement and the solution. 2 minutes and 3 minutes discussion. This one. He will join. He will send you a message in the chat. Sure.
That's why I sent the picture. Because if it's not enjoying, then sharing the picture will be difficult. Okay, I'll be done.
Excuse me? Just one photo.
Yeah. Good news is like our students from India, they go on hackathon in India. And the lady, you might have seen her. Yeah, there was, it's only out of 70 teams, 4 teams from Tanzania. Wow. Yeah, 7 years. Yeah. They got good money.
Yeah. What is the price money?
3 lakh Indian rupees.
300.
Okay. I'll be. Don't forget about my child. Huh? Sorry? You want chair? Okay. I'll be.
You want to try here?
Anything else? That is in the night. So that you can focus on work at the moment. If I give you that. Okay, I'll be back. Bagia?
Yeah, anything that you like.
Everything is
except for pili-pili.
Breakfast yenyewe sana.
Lakini kuna mitoni pale. Sio mzuri.
Angavu, yani sio mtoto. But it's special. Hata gharama itaenda hapo chini.
Leo unajua mambo mengi hapa. Huko chini kuna nyumba.
Bilioni hata.
Watu wa records. Labda. Mweke. Yaani ukiona mtu ana jina la mama. Hao ambao wana majina yasiyoeleweka wanaokuja kuongea na amekunyosha. Kwenye kilo simkuni.
Lakini unajua ni healthy. Unajua ni healthy.
You don't need to sit at the main table. It's just to help with the technical part. Okay. Sure.
Das ist der nächste Connection.
Vielleicht eine E-Mail bombardieren zum Verbraucher. Ja. Genau, jetzt von zu Hause.
Jede Woche eine E-Mail.
Did you join the meeting?
Yes, it does. Ach, siehst du, ich habe noch gar nicht mitgeguckt, weil ich das nicht gekriegt habe.
No, I was starting to learn like to drink more like
Das liegt? Ach so.
So
zu Hause ziehen sie an. Alles verkauft. Ja. Ja, was für Konferenzen, was für Center.
Do you hear me? Yes. Will we start in 3 minutes?
Yes, it's okay. Just let me know when it's going to take place.
Ja.
Okay. Nema Devota, let's continue. Mick, you can hear me, right? Mick, can you hear me?
Yes, I can hear you.
Thank
Yes,
you.
I can hear you.
Before I get, so let me just check, yeah. Before I give you the floor for your presentation, I will give Chibe the opportunity to, because we also were interrupted during your presentation, Chibe, no, Shihib, sorry. Maybe you can once again refer to your problem statement briefly and explain the implementation and maybe also the algorithms which you developed briefly. Can you do so? Thanks. Shihab, can you continue? In case that you can. Yeah, that would be great if you can once again refer to the problem statement briefly and just explain the algorithms you developed and how they have been implemented.
Can you see my screen now?
Yes, but briefly please, because just use 2 minutes because we have to continue. Thanks.
Well, for the problem definition here, we found a problem in detecting community detection in complex networks. Therefore, we proposed to use an approach, which we name it contextual graph clustering, to detect these communities using the part of graph neural networks. Our solution composed of 3 main blocks: embedding blocks, fusion dynamic block, and a clustering block. The embedding block track the embedding for each feed separately, then it will add the context to each embeddings and fuse them using the average function. Then we will apply the K-means algorithm to the extracted embeddings in order to detect communities. In the embedding blocks, we use the graph encoder as the core main solution for the graph embedding. For the fusion and context block, we introduced the context coefficient, which is a numerical representation that represents the importance of the view embeddings. its values can vary from 1 to -1, and the closer it is to 1, it's the more important it is. Also in the clustering block, we did like Kami algorithm, and it would use an empirical approach to determine the optimal number of communities. The metric that we use to evaluate the best number of communities is the silhouette metrics. And this metric evaluates the resultant communities in terms of similarity within the same community and integrate it in a dashboard for a real client provided by BI for your enterprise. So the data set was provided by them. We did apply our approach. We extracted the communities and we visualized that in the dashboard. In the respective section, we here give you like an example of the output. And you can see here we said that our output was clear, but we're missing the more explainable part. It was like missing, like we know that the community are influenced by the professional context, but we don't know how to present that in a more user-friendly to non-technical person. Therefore, I think that's the part we should work more on.
Yeah. Referring to that slide here in Sheetup, why do you call it explainable EA and not AI? Is this a mistake, a spelling mistake, or is it just unintentionally? Sorry?
I think it's an artificial intelligence or artificial.
Okay, no, it's just a spelling. No, it's fine, it's fine. I'm just asking, it's fine, no. Okay, Sheetup, thank you. I think we have to move forward regarding because the time is running. Thank you so much, and for the presentation, it was pretty much clearer than before to me. Thanks again, and sorry for the delay and asking you again to be with us. So one. Oh, excuse me. There is one question. Sorry.
No, I just agree to your explanation. Sorry.
Okay. So that was a comment. Thank you, Helmut. Sheetup, once again, thank you very much, and looking forward to meet you maybe personally once I'm back in Europe together with Abdel Karim. Bye.
Yeah.
Thank you, Sheetup. Thank you very much. Okay, Mick. Mick, can you hear me?
Yes, I can hear you.
Perfect, Mick. Then I would like to ask you to put to share the screen with us. And I would like to give you the floor directly. Make use of your time. And once again, sorry for being late. This was not under our control. Let's call it like that. Okay. Mick, go ahead.
Okay. Thank you. I hope everyone can hear me well.
Yes, we can. Very well.
My name is Mick Knight. Perfectly. My name is Mr. and I am delighted to present you today our first paper towards the contribution to the development of sustainable target value streams with learning, considering material flow cost, virtually here at the first international conference on technological advancement in embedded and modulated systems. Initially, I want to explain something about the author profile and research interests. So the paper, which I will present in the next briefly 10 to 15 minutes, was elaborated by Professor Engel and myself, Mick Geister. Professor Engel, who is currently ill, so he can't participate today, is Professor for Production Management at the Yale University of Applied Science, the Department of Management, Information and Technology. Additionally, he has 15 plus years of experience, especially in lean management and lean management applications. To talk about my background, I studied engineering and management with a specialization in industrial engineering and business management. And I recently, in August, started the YADE 2 Pro doctoral scholarship program, which is a cooperative program supervised by Professor Mark Gomez and Professor Engel from the Yale University. My specific research interests are value streaming and e-management in context digitization, and of course other affiliated topics like data science, ML and AI in production. About my paper and project, my project is of course funded by the Yale University of Applied Science, and it's especially relevant for improvement experts or lean managers come to the edges of their capacities with rising automation and increasing complexity of data. So let's hop into the presentation. So in my presentation, I will first give you a quick introduction into my topic. Then subsequently, I will explain a little bit about our methodology and how we approach the topic in our first paper. And of course, you after that some background information in value stream mapping, especially applied, and its extension on material flow cost accounting. Then we'll head into results and end with conclusion and directions for future work. So value stream mapping is a well-established e-management tool. It's been around, I think, about 20 years. It was invented by Mike Rother and John Schupp, and is generally employed globally for process improvement, especially in context of brownfield planning, so optimization purposes. With an application, it's typically like that an improvement team follows a pen and paper approach, often also pen and paper and stopwatch, goes on site and is tracking the stream in a picture, so in a value stream map. And after that, consequently, are evaluating these maps, especially in terms of lead time. This is also a focal point that the concentration of this method, of this traditional method, is on waste types that are accessible via lead time. The same time, especially importance of resource efficiency gains in industrial production, and especially from my experience here in Germany. Just to name an example, the electricity price for a new contract in industry, including electricity tax, has almost doubled over the last 10 years. This means energy, resource efficiency prices, oil prices are influencing the way improvements should work and should be conducted within corporations. Geopolitical developments and of course the climate crisis, but also pose challenges in the direction of resource efficiency. Therefore, value stream mapping in former research of our by the concept of material flow cost accounting to enable that energy and material based way can be considered. Now we have the huge complexity of data using with digitization and automation of industrial production, and we asked if how will e-manager work in 5 years? We focused on application and its advancement in the context in this action. In step 2, we transferred our findings to elaborate a hypothesis, which is basically our paper, which we have produced here. And our hypothesis basically consists of four subsequent ideas or steps. Initially, we have the extension of value stream mapping to include material flow cost accounting, to have a holistic optimization. Then within this within application of this, we need extensions of wastes, we need guidelines for optimization, and we need an ideal state as a vision which we are moving toward. Then we need the value stream to be digitized flawlessly, so that we have access to all the data. We need to select KPIs, so which can use for the model concept. And at last, we need to elaborate the machine learning concept for application and further development. So now let me give you a quick insight into the background of value stream mapping. So basically, value stream mapping, invented by my co-author John Shook, is performed by an improvement team, often by lean managers. Initially, the current value stream is mapped. We have here on the picture on the left side, we have a supplier with the customers, and we have the internal end-to-end processes with inventories. Then on the bottom line of these small pictures, you can see the so-called lead time ladder, on which the lead times are evaluated and then used for optimization purposes. After the current situation is mapped, the improvement team uses the 3Ms. 3Ms is originating from the Japanese Muda, Mura, and Muri, which basically represent the classic wastes like transport, inventory, unnecessary movement, uneven utilization capacity, or even overloads. These types are used to allocate wastes within the value stream, and in sequence, the same improvement team uses defined guidelines by Rother and Erlach. For example, some of these guidelines are production according to customer time, or bottleneck control, establish a bottleneck control to optimize this value stream. This you can see on the right side, an example, conceptual example for a target value stream. Yes, this is then optimized. Everything is moving towards the ideal state defined by the Toyota production system, which means 0 defects, 100% value creation, one-piece flow, and of course safety for the people. Problem with these methodologies, the limitation that these value stream mapping is limited to waste that is accessible via lead. So costs, resource efficiency is hardly be integrated. So as a result, we have incomplete process improvement solely favoring the lead time. Now, to leverage this, value stream mapping has been extended by material flow cost accounting. This is an extension based on standardized DIN norm that enables material and energy-based wastes. On the picture on the left-hand side, you can see the representation of material flow cost accounting, where we have a product. Initially, of course, that consistent implementation of digital techniques within the production system or the end-to-end value stream, how you want to call it, so that we maximize the availability of information and KPIs. So, of course, the information needs initially accessible so that we can use them. Now, when we have the availability, we thought about possible cases for the featured model concept. Therefore, of course, we wanted to go in the direction of value mapping, material flow cost accounting, and we choose to use on the one hand side traditional value stream mapping KPIs that are really time focused or lead time focused, like lead time, cycle time, changeover time, uptime, and we want to use also the extended value stream mapping KPIs like product input, which is then subdivided in different costs, so that we have a truly holistic overview and can later perform holistic optimization. Here, a little insight into the results, our ideas for the model concept. Of course, the overall target is the sustainable target value stream discovery, or assisting improvement team in the discovery. Within our thought process, we thought about 3 development components, which we could define. We basically need task, rules, and the algorithm. Our task, the content task for the digital application is to assist improvement teams in discovering waste optimized and sustainable target value streams towards the ideal state within the industrial environment, so specialized in the industry. And the focus hereby is on the methodological transformation process from KPI's current value stream to the target value stream. Then as a second component, we need rules according to which the digital application is supposed to solve these specific tasks and of course being able to learn. These rules are on the one hand the traditional forms of waste, but also extended, and the guidelines which are used to perform the transformation. As the third component, we have the machine learning algorithm, which we have not yet decided on, which would be the perfect fit. But basically, we have the three top categories of supervised, unsupervised, and reinforcement learning. And in the end, in the overall application, these developed digital application should be able to use a KPI-based current value stream as an input, then evaluate everything, allocate wastes, and perform optimization according to the guidelines, and give us as the output the target value stream, or give us hints for the improvement team to develop the target value stream.
Mick, sorry for the interrupt.
Conclusions are...
Mick? Oh, you're already come. No, I was just saying that you just have 1 minute left, but you are going already to the conclusion. Sorry for that.
Yeah. No problem. Value stream mapping continues to exhibit high potential when it comes to maximize value creation. Extending value stream mapping by the factor of material flow cost accounting enables to leverages the lead time exclusivity and integrates the resource aspect. For us, it seems distinct that we need a digital application in the future to be able to use these lean management methods and perform optimization. And our hypothesis is that machine learning can be utilized to discover new target values. So our next step is the presented model that we further develop the presented model concept as a hypothesis and evaluate it. Thereby we want to keep the human in the loop, so we don't want to be wanted to be fully autonomous. We want to keep the human in the decision process inside. We need therefore investigate in detail which algorithm is suitable. We need to clarify how we ensure transparency and understandability so that the lean management team can understand our approaches. And we need, of course, to train, test, and validate the application in laboratory and practice. Here are my sources. And of course, thank you for your kind attention. And are there any questions, remarks? Of course, I'm happy if you get in touch with me or Professor Engel. Thank you.
Thank you very much, Mick. I'm pretty sure we will have some questions around. Maybe I can start. Mick, when we discussed about your initial work and of course also your intended PhD work and the addressed scientific value out of it, of course we have to talk about the difference between your approach and the existing approaches, for instance material flow networks used in the software tool Umberto. And they extended also their work regarding some material flow and costs about material and energy. So what is the difference, especially when it comes to the discussion about lean management? Can you just point out a bit the difference between your approach and the already existing approach coming from the work of Hamburg, the IFU and the IFOI institutes dealing with material flow networks and material costs and energy costs?
So basically, this approach, I can maybe jump to the slide. This approach builds up on the development of material flow cost accounting in combination with value stream mapping and lean management. What is unique about that is that the optimization is based on all the lean management principles. The lean management principles, like we have defined wastes, we have defined guidelines for optimization, are established since a long time. I have not seen someone transferring it really into the digital world and using it. So I have not specifically discovered something like that. And of course, I don't know in detail if material flow cost can be used by others, but especially this lean management combination is used since a long. It has proven since a long time to use these management guidelines for saving money and optimization purpose. And so it would be, in my opinion, be really valuable to use that.
Okay, if you really want to go towards saving money, of course you have to make clear about the differences, right? Because this is, once again, this doesn't already exist. They did it over the last 10 years, more or less. But I'm pretty sure that by including your machine learning approach, and especially talking about lean management, going towards, yeah, I took a picture out of it, what you mentioned, it was quite interesting. So the difference between, by adding it to the traditional value stream mapping to the extended one, actually this is actually what you are doing, what you intend to do, right? And to point out the difference, bringing machine learning approaches in it, and of course having this additional value out of it. And this might be in fact the difference to the existing approaches. But you have to demonstrate it. Right? Am I right? Or
okay.
Am I right?
No, you're definitely right.
Okay.
Yeah, of course, this extension is the new thing. With, of course, sustainability is a lot of research happening in material, of course, also in the cost domain. But this specific combination, I think, is unique.
So the upcoming tasks for you are pretty much about how to select the machine learning algorithm, how to adapt it, and to create a model out of it, and to demonstrate it via a target value stream at the end. Correct? As an output?
Yes.
Okay. Good.
Yeah.
Good. Okay, thank you so much. Looking into the room, is there any further question? Yes, Helmut?
You said you will keep the human in the loop. To what extent will you keep it in the loop? Just for monitoring, or they are still in a control loop?
I think we saw in PDCA cycles a typical method plan do check. And we want our algorithm to exactly act also like that. The plan do is then performed by the algorithm. The checked phase is performed halfly by the algorithm, and of course the other half of the check phase and the act phase in practice is then performed by the human. So the human doesn't leave the loop, because there are always some complexities in the environment, because production is not always the same. We have, for example, workshop production, or we have continuous production. For example, it's also different when you produce medical devices or motors. So there always would be advisable to keep the human and let him check.
Okay, thank you very much.
Thanks, Helmut. There's another question coming from Abdel Karim.
Hello, I have a question, exactly the second part from question of Helmut, keep the human in the loop. It means you mean with keeping the human in the loop that you human interact in the act on the check phase. How do you handle this feedback, this human feedback, this, we can say between parentheses, this evaluation, this human evaluation? How do you handle it?
Yes, of course, I don't know the answer so far, but in continuation of this work, we need to focus on these points and need to consider what role the human exactly will play.
Thank you, Mick. Any further question? Maybe from the online participants, is there a question or a chat message? It's obviously not. Participants online? Questions, remarks, hints? This is not the case. Then, Mick, thank you very much for your presentation. We will meet pretty soon once I'm back, but well done, and yeah, thanks again.
Okay, so the next presentation is on a systematic literature review towards standardization of business rules discovery in the context of process mining by MENA.
Yes.
Okay, Mena, can you share your screen?
Yes, okay. I hope you can hear me and see the slides.
Yes, please proceed.
Okay. Hello everyone. Today I am presenting my contribution to this conference, which is the paper titled Systematic Literature Review Towards Standardization of Business Rules Discovery in the Context of Process Mining, written by Minna Wael and Gamal Qasim and presented by me, Minna Wael. Let me first introduce the authors of these articles. First, the Associate Professor, Dr. Gamal Qasim, Associate Professor in the Department of Business Informatics at the German University in Cairo, Egypt. His research interests are related to process mining, ERP, workflow, and business process management. And me, Minna Wael, I am an assistant lecturer, Department of Business Informatics at the German University in Cairo. And my research interests are related to process mining, machine learning, and business process management. Let's start by the agenda for today's presentation. I will start by an introduction, research, including the main concepts of this research and the research problem. Then we'll move to the methodology used to solve the research problem. Then we will discuss the results of the methodology. Finally, we will conclude and for sure mention the limitations and future work. Let's start with the introduction. So let me first introduce some of the main concepts related to this research, which are related to the business process and business rules. So the business process is a set of activities that are performed by people, by machines, or by systems in order to achieve a specific business goals. The other important concept is the event log, concept of the process event logs, which are, as you can see in this actually figure that I included here. This is an example of the event log, which actually records the execution history of the business process through the information system, and actually it is time stamped. And from here we will discuss the concept of process mining, which is using of different techniques in order to analyze this log, in order to detect the process problems, understand the process behavior, and potentially improve the business process. To the other important concept, which is the concept of the business rules in general. These are statements that are used by the business in order to understand or to define or constrain some aspect of the business. And the business rules from a business process perspective are statements that describe, that reflect the behavior of the business process. These rules are considered the basic structure of the business process, and they are incorporated in different patterns within process data. Okay, moving to the discovery of the business rules from business processes, it was massively mentioned in literature that it has a lot of advantages, including allowing the analysis, the verification, and the improvement of the business process, reducing the costly mistakes that happen during process execution, and helping achieve process objectives. And in order to discover the business rules from the business process event logs, data mining is considered a common method to discover the business rules in which different data mining algorithms can be applied in order to find the different patterns within the event log data. Moving to the research problems, so the business rules, as I mentioned, discovered through the application of data mining are related to different pattern types within the event log data. However, research papers that identified those different pattern types related to performing different data mining tasks on the event log data were hardly found. These kind of patterns are important for many reasons. For example, they can be used to the event log, they can be used to guide the process analyst of the different analysis objectives that could be reached through the discovery, through using data mining for the discovery of the business rules from the event log. They can be used to classify the business rules according to the different pattern types. That's why the goal of this research is to conduct a systematic literature review. From now on, I will call it an SLR. In order to identify the different pattern types related to performing different data mining tasks on the event log data and identifying the different analysis objectives for the discovery of the rules from event logs. Moving to the methodology which is conducting the systematic literature review. So the review process proposed by Imran Ita in 2022 was followed. We start by the review planning, then conducting the review, and finally reporting of the results. Starting by the first step of the process, which is the review planning. It consists of identifying the purpose of the review, formulating the review questions, and identifying or setting the review protocol. For the purpose of the review, as I mentioned earlier, is to identify the different pattern types and the different analysis objectives. And this purpose was used in order to develop the review questions, which are two review questions. The first one is what are the common pattern types related to performing different data mining tasks or event logs to discover the business rules. And the second one is what are the analysis objectives for the discovery of the rules from the event logs. The review protocol accordingly was set according to developing the research terms, selecting the databases for searching, and developing the inclusion and exclusion criteria. The review questions were used to identify the main research terms, which are, between brackets, business rules or patterns, and data mining or mining, and business process or event log. The databases chosen to be searched are the Science Direct, Icta-Emos Explorer, and Google Scholar databases. For the inclusion and the exclusion criteria, all research papers that are written in English, papers that focused on the discovery of the rules from the event logs, and research papers that use data mining as a technique for the discovery of the rules was included. For the exclusion criteria, research papers that focus on the discovery of rules, however, from other sources than the process event logs, or research papers that did not use data mining algorithms in order to discover the rules were excluded. Moving to this step for the review process, which is conducting the review. A manual search for conference proceedings and journal papers was performed from the 3 selected databases with the identified search queries, and to conserve the ability to find as many articles as possible, the review was not limited to a specific time period. Accordingly, the total number of articles found at first was 605. After that, the title and abstract-based screening was performed. That reduced the results to 100 articles. After that, text screening was performed according to the inclusion and exclusion criteria, which reduced the results to 40. And finally, a quality assessment was performed on the 40 articles. That reduced the results to 31. Moving to the results of the review. For sure, I cannot discuss all the results. They are thoroughly and in details explained in the research itself. However, I'm going to summarize the findings. According to regarding the first review question, which is related to the finding different pattern types, the SLR findings identified 3 commonly and repeatedly pattern types that were mentioned or discovered in literature. The first pattern type is the frequent patterns, which actually reflect the frequently associated event log attributes. The second type is the rare patterns, which reflect infrequent associations of event log attributes. And the third type is the classification patterns, which reflect the classification of the event log attributes according to a class label attribute. Moving to the second review question, which was related to finding out what are the general analysis objectives for the discovery of those rules from the event logs, and it was found that there is a full list of different analysis objectives. I included some of them here. For example, process model construct analysis and prediction, process performance analysis, decision point analysis, discovery of low cost, high utility process patterns, causal relationship discovery, root cause analysis, temporal patterns discovery, staff assignment / resource allocation rules discovery, detection of violated process policies, access control rules discovery, organization structure and organization roles analysis. In conclusion, this paper conducted a systematic review in order to identify the different pattern types related to the application of different data mining tasks on the event log data, and identify the different analysis objectives for the discovery of business rules. The results identified 3 different pattern types that were commonly discovered, and the results also identified a list of different analysis objectives and mentioned the common data mining algorithms that can be used to discover those business rules from the event logs. We believe that those results are important in order to design future process mining analysis system in order to develop frameworks to standardize the process of business rule discovery from the event log in order to understand, because this was not mentioned in literature, how to apply the different data mining algorithms to discover the business rules related to the different pattern types from the process event log. It is important to classify the business rules or provide a classification of the business rules according to those pattern types, and to guide the process analyst who wants to analyze the process according to different process perspectives on how to use data mining and what to expect as an analysis objectives. Moving to the limitation of this research, so the main limitation is missing some relevant information or relevant references due to performing a manual search process, selecting only 3 databases for the search, selecting only the English language. That's why from future direction, it is recommended to perform an automated search instead of the manual one, include more databases for the search, and search for articles in other languages than the English languages are differences. Thank you for your time and attention. I'll now answer any you have, and you can reach me via email to discuss and share the information.
Okay, thank you so much, Mena, for the well-informed presentation. So maybe I can start. I would like to understand, so based on the 3 obtained data mining algorithms, which one is mostly used between the 3 obtained?
You mean those, right?
Yes.
So actually, the 3 were actually important. I cannot say which one is more important or mostly mentioned, because each one has its own usage. Classification patterns they were equally used in literature.
Yes, my interest is to understand, based on the paper which you have reviewed, I think you come up with these 3s, and I would like to understand maybe the first one is the one which was mostly used based on the papers which you have reviewed, or it was just the arrangement of those algorithms?
As I mentioned, actually, I did not find one of them that were mostly, or the most common one is the frequent patterns. However, the rate patterns and the classification patterns actually are also able for other purposes than the frequent patterns, or discovering the rules related to the frequent patterns.
Thank you so much. So, any other questions?
I do as well. Oh, no, stop.
Hello, thank you very much for this presentation. I have 2 main questions. The first one is, I haven't understand what is your motivation to conduct this research. Can you please say me why you want to do this literature review? That is the first question. The second one, after conducting this literature review, what are the outcomes? Can you please explain what is your finding after doing this literature review? Thank you.
Yes, so first for the first data mining, however,
Mena, sorry for the interrupt. We lost you for the last 3 sentences. Can you answer again to the question of getting? Sorry, it was a technical problem.
Yes. Okay. Yes. So I was doing my master thesis, and I wanted to develop a framework for the discovery of those rules from the event log. However, I did not find any kind of guidance on what are the different types of business rules, or what are the types of patterns that can be discovered from the event log. I did not find any kind of collected or a classification of information related to what are those types of rules that I can discover in order to develop this kind of framework that can be used by the process owner. So I first had to conduct a systematic to collect this information first in order to develop this framework. So this is the main important for this review.
Okay.
So regarding the second, yes.
I think Abdel Karim was more referring about the outcomes of it. Maybe you can just
help me discover business rules related to the frequent patterns that happen in the event log attributes, or find rare patterns that are infrequent associations that happen in the event log attributes, which actually could help me understand what are the rare frequencies that happens if any kind of violations are happening inside the process execution and so on, and help me reach business rules related to classification patterns, which means that I am classifying or using decision trees in order to classify those attributes related to a class label. This is the first outcome. The second outcome is related...
I get the point. Thank you, Mina.
Yes, okay.
Thanks, Abdel Karim, and indeed it was a bit clearer. Exactly the slide, Mena. Can you... This, what you presented here, is the outcome of the second review, and the questions out of it.
Yes, question.
Yeah, okay, so so this individual point appears to be quite interested when it comes to, or interesting when it comes to the event logs, right? What is the let's say the link to the data mining part, or was this just kept out? For instance, the yes, sorry.
Yes, there is actually a relation, quite an interesting relation between this analysis of objectives and data mining. Because, for example, this is actually explained more in details in the article itself. For example, in order to perform the decision point analysis, as you mentioned, this is actually this is important in order to understand if I'm taking a decision inside the process. Why sometimes I took a path and sometimes I took another path. This is related to performing a classification. This is related to the classification patterns and using decision trees in order to find this kind of analysis objective. So every one of them actually uses different data mining related tasks in order to find them, in order to discover this kind of analysis objectives.
Within your research, which appears to be very, very interesting, I know this topic since your supervisor is quite well known to me and the things he is doing. Can you just give us an example for a business rule driven out from an event log? Just a visible, tangible example out of it. So what could it be? And do you have a company working with it in cooperation?
No, actually, I did my own case study on data that I collected from other research.
Okay, can you give us an example for a business rule derived from an event log? What could it be, just to visualize it?
Okay, so for example, if you imagine a process in which you have to take a decision at some point in order for example, for giving a loan to a customer or not giving a loan. This is a decision that is taken in the process.
Okay.
So I go inside the event log data and I analyze through decision trees when this happens and when this happens. And the business rules that states that if a customer has he will take the, and if the customer has customer loans below, etc., then he will not take them. This is the business rules.
Yeah, gratitude for this nice presentation. I think there's still some things to be done, but I'm pretty sure that with Jamal Qasim this would work, or will work quite fine. I wish you all the best. Many greetings from us to Egypt, and also many greetings to Jamal, and yeah, hope to see you also soon all again. Thank you very much.
Okay, so the next presentation is on So the next presentation is on continuous feature vector constructions for incremental learning on constrained devices by Daniel. Daniel, can you hear us? Please proceed.
Can you guys hear me?
Yes.
Can you guys hear me? Okay.
Yes. Yeah.
Great. I'm sharing my screen now. Yeah, thank you. Hello everyone, my name is Daniel. I am a doctoral candidate at the University of Oldenburg, and today I will present a paper that is titled Continuous Feature Vector Construction for Incremental Learning on Constrained Devices. In this presentation, I have divided the topic into 4 parts. Just a second, just not passing. Yeah, into 4 parts. First, I will introduce the topic, giving you some background to understand the need for the product proposal. Then I will introduce the actual approach that I'm proposing in order to continually construct features that can serve to train machine learning models. Then I will cover some of the aspects that I consider important regarding the experiment and the discussion of. And at the end, I will present a summary and a couple of aspects that are good to consider for future research. So, as an introduction, for those of you who are maybe not familiar with the term, data streams are endless series of values about a particular topic, and these values normally or always come together with a timestamp that is associated to the specific value. For example, here on the left side you see a time domain that is incrementing row by row, and on the right side you see a specific value that is just associated to this timestamp. As you can see, the values are dynamically changing over time. Now, this type of data is really important because it is actually found everywhere. So, a few examples is transactions, online purchases, web activity, and that release sensor observations. And I have underlined here sensor observations because this is the focus of the proposal. And so therefore, sensor observation, when you observe a sensor, you get data flows or data streams, and a sensor data stream can be thought as a type of a sensor that is observed on a regular basis, and usually the frequency of sampling is very high. Some examples include measuring the temperature, measuring the speed in a car, the acceleration, pedal position, the gear number, and so on. So you can name many more examples for sure. So then, what is the goal of using the data in general is to derive into an intelligent action. So we want to make decisions, and in order to make decisions, it is really important that we consider the data to support the decision. It's not merely or based on our intuition anymore. And then, before we can make the actual decision, there is a reasoning process that must happen. And this reasoning process, we as humans require 2 things. On the one hand, we require knowledge that these or subset of true beliefs about specific domains. And we require also facts. And the facts are coming from the data. The problem sometimes is that the data that is raw and is not prepared requires a lot of processing in order to get to a point that you can use it. In contrast, when the data is already semantic, that means that it has explicit context, and the preparation becomes much lighter, and you can basically almost directly use the data as a given fact. Now, regarding the data streams, what I'm arguing for is that the meaning of the sequences of this type of data, this time series data, is quite important to consider, and not only the individual observations of a sensor. To name an example, if you are measuring the speed in a car, you might find like at some point you have a 28 kilometers per hour, but this is not telling you anything else about the sequence that happened before, and probably something to let you predict what will come in the future. In contrast, we have a sequence here, and in here you can basically see, for example, that you have high values around 100, and then suddenly it starts to decrease, and then at the end you have values around 30 kilometers per hour. If you have the proper model and the proper domain knowledge, you may be able to infer meaning that is understandable for non-humans as well. So, for example, instead of having a sequence, you may have the actual meaning of this data that says there is a car that is moving at a road whose speed is 100 kilometers per hour, and then the speed decreases, and then probably the car entering a residential area at 30 kilometers per hour. So again, the meaning of the sequence is important, and this is the argument for this paper. In order to retrieve the meaning of the sequences, there are many techniques available, but nowadays we have seen that machine learning techniques have proven to make excellent predictions in tasks that are specific, in tasks where you want the maximum represented by this type of data, and they all are grouped into this so-called one-pass constraint. This means that you normally have constrained resources in some devices, like for example, in a connected car, you cannot have unlimited computation or unlimited storage or unlimited bandwidth. So that means that must do something with the data point that you see, otherwise this data point will be lost forever. So before I present the actual approach of this, I would like to locate the approach into a much bigger solution for sensor data semantics. I have taken the example of a connected car where you have something that is occurring on board and something that is occurring off board or in the cloud. We can distinguish three scenarios when you want to derive or to deliver these actions to an application that is classifying the...
Can you just, sorry, we lost you for 15-20 seconds. Can you repeat the last sentence again, please? Sorry for that.
Okay, so I was telling you that I have taken the example of a connected car. What I'm presenting here is also applicable to other type of sensor networks. We can distinguish three scenarios. One scenario is we will have isolated applications that are consuming from raw data. Raw data here is represented with these black circles. What happens here is that the application logic is quite extensive because you must handle all the structure, the data transformation, the preparation, the data in a shape that you use to train a model, for example. I did this experiment for modeling dangerous driving events. Although it works for the classification task, there are some limitations here because, as you can see here, the outcomes from the applications are not sent back to the actual architecture, so it's not being reused. And also the application logic is quite extensive, which is a problem because it's causing a lot of repetition. The second approach then, it's something that I cover later, I propose to have like a basic preparation for the data, classifying different types of data streams into either categorical or numerical data streams, which are covering most type of the sensors that are available, and then doing some semantic annotation so that you can use these. And the third scenario is basically combining these previous two, in which you have the same or similar application, but not consuming from the raw data, but from the outcomes from the basic analysis. So these approaches have been partially covered in the publications that I have listed here, so I invite you to also refer to them. But this is the interest of having the decision-making process. You have some reasoning, and what is missing is the facts. So if you use traditional machine learning, you have a subset of the time series data, and then you train with examples, and you make the prediction. But in here, this is use case specific, and it is assuming that you can iterate over and over the data, and this is normally not the case with sensor data. Then with the Bayes analysis that it was shown in the second scenario, you can basically apply generically to different types of streams, but you cannot cope with the complexity of some of the models because you are handcrafting some of the features, and of course it will be limited to your domain knowledge. So the idea here is to combine both into this. So you take the outcomes of the handcrafted features, you use the handcrafted features to automatically build continuously a feature vector that can be fed into a machine learning model of the data stream and make aggregation out of it. So in this case, the benefit is that you can allocate just a small memory size to do the computation, and then you forward the outcomes to another layer or another window to cover like a larger amount of time. And in the end, by every time you get a summary, like here, S-1, then you construct a feature vector that is composed of the concatenation of all these summaries that are listed in the window W. Then the features that you may have are quite, you have the freedom to select what the feature you want, but the idea is to be as lightweight as possible, and for that I have proposed to basically consider the trend of the system, so to understand that how is it going? Is it going upwards, downwards, sidewards? And with this information, you can also compute the intensity of this trend and then combine it with some other statistics. But the model is open to also consider other features. To test this, I reuse a previous experiment where I was classifying the driving style and the maneuver, recognizing whether the driving style was normal or aggressive. And in contrast to the previous work, in this case, I tested the so-called frequential evaluation. That means that you don't train the model completely in advance, but you send the model one example, the model makes the prediction before you send the next example. So this is basically helping the sensor domain or the sensor data domain to cope with this usually changing information. In this case, these are metrics. These are called the kappa statistics. This is for the chance classifier. So basically, it's telling you how good is your classifier doing compared to if you would do the classification just randomly. And the second one is how good your classifier would do compared to if you just take the majority of the outcomes that have happened up to now. I selected four properties: acceleration, lateral and longitudinal, the pedal position of the accelerator, and the speed for this specific example. And the model that I have tested is an online version of the decision tree. It's called the Hoffman tree, or also known as very fast decision tree. So you can refer to this. This framework is called SK Multiflow or Scikit Multiflow. There is a new version called River, where you can have this type of online machine learning models implemented. As of the results, so there are two tasks for classifying the aggressiveness. The idea here, so that the highest the number of the statistic, the better the performance. So you can see with this orange dotted line, the average of the outcomes for these specific statistics, and you can see that it's always above 80% in what here above 75% in all of the cases. The peaks that you see here downwards, they are because this type of online learning tends to forget previous data example. This is to be able to adapt to changes that suddenly happens. That is why you somehow see peaks and then the model recovers. Last but not least, here on the right, I have conducted an assessment with data that was not labeled regarding maneuvers and aggressiveness, but just the driver was telling an instruction to drive normal or to drive with a moderate aggressiveness or to drive fully aggressive. So this is how the models are performing according to, they are ordered according to what was expected. And here in this last part, what you see here is 64%. In parallel, I did a person, and they labeled down the perception they have in this specific trajectory, and it was around 67, so it was not that far from the outcome. Then, to summarize the topic, basically the idea is to reuse this part of a larger picture or larger project for sensor data semantics. And the idea here was to show that these type of automatically built feature vectors can be used to discover much complexer structures or outcomes, in this case the dangerous driving or anything else that for humans is difficult to model by hand. Then beauty is that they are use case specific. So if you define the time window that is covering 10 seconds, then this 10-second window will be advancing, and sometimes there are events that might be shorter or larger than this 10-second window, and this is not going to characterize well. So there is work existing regarding the adaptive windowing, so I think it makes sense to have a look at them and try to include them in this approach. And also regarding the training data, which is not a specific problem for this experiment, but in general, finding the proper data to train, especially with this online step, you require the data to be labeled before you can feed it to the machine learning algorithm. So I think a semi-automatic way of obtaining these feedbacks to retrain or to fine-tune the model is also necessary. With that, I conclude my presentation. Thank you so much for your attention, and I am open for your questions if there is any.
Okay, thank you so much, Daniel, for the very nice presentation. I would like to welcome if anyone has a question, comments for Daniel.
Especially while Daniel is going to defend his thesis in the next week, no, sorry, in 2 weeks. So it would be very nice to have some input on this presentation as well.
Yeah.
There's one from René, there's one from Helmut,
yes,
there is one from Lucien. I don't know who was the first. Let's start with René.
Hi Daniel, thank you for your nice presentation. Could you please go back to the slide with the reasoning part? I think we lost the connection there for about 5 seconds, and then I wasn't able to understand the last two workflows you explained.
Okay. You mean this one?
We don't see your slides. We just see your wallpaper at the moment. Yes. And there was a good slide. No, again, only the wallpaper.
Okay, it's taking a few seconds to load.
Okay, and after the second flow graphic, we lost the connection, so it would be very nice if you could explain the third and the fourth.
Yes, sure. Yeah, so the third one, you mean this one, machine learning on streams.
Yes.
So when you have traditional machine learning models, you normally have all the data set available, and then you use these training samples, and then you rearrange these samples as you wish. So you do iterations. The difference here is that in this setup, machine learning on streams, or it's also referred as online machine learning or incremental machine learning, you don't have this possibility. So it's assumed that you cannot rearrange the data as you want, but you have just one sample, and you need to fine-tune the model with one sample. So in here, the classification is, or the classifier is trying to make a prediction from the incoming data, and then with this check the accuracy of this prediction, and then use a new example to see if this didn't match, then you fine-tune the model. So this is the difference. And the third basically is a combination. That's the idea that I'm coming with this paper, is combining the base analysis that I have for another process that is semantic data with the more complex tasks, and the idea is basically to have the explainability of a basic analysis that you are gaining from here, but also to be able to cope with complex predictions that you gain with these machine learning on streams. So it's a combination of both. That's the idea, to enable something that can cope with these four criteria. I hope my answer was clear too.
Yeah, I got it. Thank you. Perfect explanation. Thank you.
Lucien and Helmut.
Thank you very much. First of all, I thank the presenter. I have been very well interested with his presentation. Maybe because I'm not in the field, I want to hear him summarizing what this science, these discoveries will solve in the domain of the science, first of all. Secondly, to highlight once again in the society the science that is presenting, what it will bring as a solution. In other words, it is to emphasize on innovation of what is presenting. Thank you.
Okay, so if I understood correctly, I will just rephrase quickly. So first one, you want to know what is the impact in the society, and second, what is the contribution of these to the science, right?
Yes.
Okay, so the impact to the society is not visible directly, but if you consider that nowadays most of the electronic devices are creating data. So most of the technology that you have at hand is on data. So we're not talking about only your intuition about solving a problem, or your intuition, or you make a decision because that's your intuition. That is going away. So everything is based on data, and you need good data for that. You need data that is explainable. You need data that can be quickly processed and quickly understood to derive the action. So sometimes there are applications that don't have, or that have some sort of a real-time constraint. So people are expecting immediate outcomes out of something. Yeah. So the benefit is basically coming later to the society, to what you can build, what type of solutions you can make with sensor data. And sensor data is quite diverse. If you have a temperature, maybe you want to control that there is no risk of fire within a lab, for example. Or it could be many things. So it depends what you build on top of sensor data. But the principle is to enable these data to be explainable, to be able to cope with complex predictions, to be generically applicable, and to also be as fast as possible to provide you with rapid insights to make the predictions. That's it's kind of an enabler. And from the science contribution part, this is, as I said, part of a much bigger for data, sensor data semantics. And the contribution here is, in general, to design, it's called an artifact or a piece of technology. And this piece of technology should be able to provide immediate outcomes out of sensor data in a way that humans can explain or humans can understand. So in this, the idea is that if you get the answer of, in this example, the driving classification or the driving style classification, the idea is if you have questions, okay, why this was aggressive, you may have an insight that this was aggressive because the speed was increasing, because the location was near an area that is residential. So these kind of things are possible if you express these at the data level.
Thank you, Daniel. There's a last question from Helmut Farsch. Helmut?
Yes, thank you very much for your really great presentation, Daniel. It's impressive, and just no question, perhaps an idea you could add. Perhaps you can use a hidden Markov process for your predictions to give them probability values. That would give you, perhaps in the future, the possibility to say to the driver, are you going?
Can you please repeat the last part, because I lost you for a second.
That was just the idea that you can give, for the predictions, you can assign them probabilities to see in advance when the driver could become aggressive in the future or in the close future.
Yes, thank you for the
just an idea.
This is a valid point. Yes, this is a valid point, and I came across this model technique for handling probabilities, especially when I presented the first scenario.
Okay.
Let me just go. So the point is just for you to have some context.
Yeah, thank you again for your great presentation. Thank you, Daniel.
Okay, I just wanted to mention that this was considered in the first scenario, and however, the scope of the main goal of this project was to improve the semantics of the data itself, and not only a specific task like classifying the drive and the style.
Yeah. And for the presentation, really well done. Thanks, and have a nice day.
Thank you.
Good. Then, Nima, I think we should close the session, this part of the session, but would you like to? Sure.
Okay, so thank you everyone who was with us in this session of artificial intelligence tools and applications. So now we are going for the lunch break, and then we'll be back to proceed with the other presentations. So back to you, Professor, if you want to add anything?
No, not Nima, everything, you said everything quite nice, actually.
Okay.
Okay, then let's have
Nima. Debuta, sorry. Yes, that's true. So that is true. So the continuation of our session is planned from starting from 1:30. We will have a lunch break till 1. I don't understand. There's either is a mistake, because if the lunch break is till 1, why is the continuation at 1:30? Debuta, can you help me on that? So now it's 12. Now it's 12:30, and we do have all planned presentations given so far. So there is a lunch break planned till 1, but the next presentation starts at 1:30. Is this a mistake, or looks like one? Yes, then let's agree on continuing 1:30. So we are just in time right now. So. Okay, so we will continue, dear participants, the online participants. The continuation will start at 1:30 as planned and given in the time schedule. Thank you so much to all, and looking forward to see you later all again. Thanks, and thanks of course also to all presenters. Thanks, and to Nima. Thanks.
Ja.
Das ist immer die Konferenz.
Ja, ja. Und meine Meinung ist, dabei ist das einfach zu viel versprochen. Ja.
Das allererste, alles was da rauskommt, muss validiert werden von einem Menschen. Und seine Entscheidung nehmen wir. Und die geht wieder rein, das ist neue Information, die Neubehandlung. Das ist das Neukalkulieren, das ist das Adaptive.
Ja, das ist das wird immer vergessen. Wird immer vergessen, obwohl er selbst so funktioniert.
Weißt du warum? Das meiste sind keine nur Konzepte. Das war nicht die richtigen Business rein. Dann werden sie die Ärger sehen.
Ja.
Die Ärger haben bekommen. Du sagst, das ist das. Dann haben wir so gemacht, dass wir nennen das Staging Area. Die kommt hoch, aber keine Flex. Die ist da, die ist Staging. Kommt dann diese Entscheidung, kriegen wir dann so. Also wir sind sozusagen die Wissenschaftler, die das machen.
Die dachten, wir wissen es auch ohne Feedback.
Genau. Aber beim Nutzen. Was? Was hat er gesagt? Ich habe mich geirrt.
Auch wenn wir dich ärgern.
Hat er bestimmt geschimpft. So, sag mir jetzt mal. Ja. Soll ich was wissen? An wem soll ich was wissen? Ich habe 100 Euro. An wem? Ist ja keiner da. Gestern. Alleine geht es.
Aber du musst auch eine keiner weiß genau, wie das Bild ein.
Aber die ganze Arbeit, die ich hier jetzt gemacht habe, die musst du dir anschauen. Super.
Ich spreche mal dazu noch.